Okay,
Yeah, I think it's
let's get to start.
okay, so today we'll be covering a series of topics and we'll focus around electrical connections, safety, and also, in a sense, we touch on maintenance and ideas behind why we do what we do and why certain things are done that way, right? So, on the table here are tools, terminals, my computer. Okay, and we have motors, right? So we will start. Let's see where we start. Okay, so I think we'll start with these, right? So I think y'all may be somewhat familiar with this, right? These are linear actuators driven by. Do you know what this is called?
Motor, stepper motor.
Stepper motor, right? And the difference between a stepper motor with a regular DC motor is that with every pulse, the motor moves a fixed distance, right?
Yes.
So that allows you to control the motors in what we call open loop. Meaning that if you give one pulse, you move one way, another pulse, you move another way. So that way, if you want to move a certain distance, you can just count the number of pulses. You don't need to measure it technically, right? But if you want more accurate control, then you need to use closed loop, right? We have a series of motors, 1, 2, 3, different lengths. This here is stepper motor, right? But it's big brother, right? And this is we would say this is a Revolut because of the way it acts, right? And if you have to break this down, there are likely 3 parts of this, though probably just 2. And we have the stepper motor at the bottom, and then we have the gearbox. Right? Do you know why we use the gearbox?
It's good.
Do you know why? Why?
Because we want to transform the torque.
Yeah, like or velocity of travel.
Yeah, because usually the motors cannot provide the amount of torque you need without some sort of medical mechanical advantage, right? So the gearbox allows that, so provides that. Then we have our HMI human machine interface, and we have our. I think this is another gearbox. I think stepper motors, cables, and PLC. Now we have our Arduino, and here we have our prototyping board. Now this usually comes in 2 flavors. The first one is the green color here, and then there's another one which is like the brownish color. That's a bit, usually it's a bit more flimsy, right? And I think outer quality, these are usual. Well, my preference is if I want to create a long-lasting PCB, I'll go with these ones. But if I want something more quick and dirty, I would go with the brown one. Because usually the brown ones you can just snap. Right? It's easier to manipulate. But the thing is, the contacts here are much better, right? This can usually
This
stay.
contain fiber.
Yeah, and the contact here, you see like the shine things. Yeah, these will last a long time. I think because maybe there's a kind of coating or something to prevent oxidation. Yeah, so that's that. And we have our stepper motor. It's another type. But these stepper motors can be driven in closed loop because we have our windings there, drive it, and then we have our Hall sensor.
Okay.
Right? Do you know what a Hall sensor is?
To measure the rotation.
Yeah, so a Hall sensor uses a magnetic field to measure the rotation of the motor, right? It uses the Hall effect. Yeah, so they usually just call them a Hall sensor, right? And this is the driver for this. So it was I want y'all to create circuit boards using this we have a few of them. So not today, but very soon I would ask you to create circuit boards so that you could just drive this using this. So this has the one quadrant driver, motor driver, right? So motors, generators are very similar. Basically, a generator, right? And a generator is a motor that works. Well, the generator is a motor that works backward, and the motor is a generator that's working backward. So that's why when you force a motor, it may supply electric current throughout your circuit. And when you have a generator, and the generator is, how should I say, is supplied a current in reverse, it may turn off the motor, right? Do you know, like in the electric vehicles, do you know what is called? Do you know what allows for regenerative braking?
Yes.
Right. So regenerative braking is basically the motors in the wheels functioning as generators. Right. So the energy gets supplied back to the battery. Right. Knowledge. So we have these, and now we have. I think this is a power meter, right? This is a power meter, right?
Yeah, that's power meter.
Okay, so this is the power meter. And connected to the power meter, we have our cable. These are high quality, silicone insulated cables, right? You will just tell. So silicone is, okay, how to explain silicone? So there are different types of some insulation, we have PVC, others we have, I think silicone is one, and depending on your use and environment, you need to be mindful of what kind of wires you use. For example, if your wires are going to be exposed to the sunlight, I would not suggest using PVC. Do you know why?
Maybe they'll burn after
Something like that. Yes, get crystallized because of the ultraviolet light. Right? And the wires now have ratings that you have to be aware of when you are actually choosing a wire to create something.
Yeah, it's quite important.
Yeah. So there's that, and also, well, we will touch upon the parameters of wires later. Then we have our connectors, right? So usually when you are creating some control box, or you're creating some product, you need to pass the wires from your exterior to interior, right? So there are different ways to do that. One way is to literally cut open the container, right? The housing. That may work if you just want to do something quick and dirty, but if you want to actually create something that lasts much longer, it's best to be aware of the influence of dust and moisture, right? So dust and moisture, they are what I would say they are hidden dangers, right? So you could think of let's say you have your printed circuit board, right?
But do you know what's the disadvantage of this?
Disadvantage of this
This because the edge is too sharp, so it's very easy to damage the cable. Right?
There's also the problem that this allows dust and moisture inside of your enclosure, right? So imagine if you have your printed circuit board and you have your tracks, right? Now your tracks are basically conductors. So if you have moisture and you have dust, it can corrode your tracks and it may bridge your tracks. So if it bridges your tracks, you can get a short circuit.
Yes.
Right? And the moisture corrosion can also cause either opens or shorts. Because eventually when it corrodes, it will create some conductive oxide, right? And that's, well, it's not really conductive oxide, it's more like the resistance the combination of the dust and moisture would be conducted. So, and then we go to the next side. So here we have our set of tools. We have more larger tools. Okay, Anderson gave you a breakdown of most of those tools, right? Or are there any tools that you do not know, you did not see them? I think he showed you this, right?
Yes.
And this one?
Yes.
And this one too, right?
Yes.
Okay, this one?
Anderson told this in last week,
Yeah.
I think. You know this? Why this?
Yes, to punch. Yeah.
Okay, and is this?
I don't know what it is.
This is it's like
Or
it's moving, yeah.
the the bird.
Yeah.
The bird is. This one is also used for the bird.
Yes.
I think you know this, right? Yeah. Yeah. This also.
Okay.
But we can use power tool. I mean the
Yes,
power.
like
Yeah.
speed.
So you use that to send
Yeah. Yeah.
This is
So-
for.
We also have our cylinder blocks. Right now, these are very useful in if you want to minimize your connections, you can create one terminal block somewhere, and then you just wire all the wires you need to, and then you just come out. Right? Instead of having it very